hashing data structure. Hashing is an important data structure, and it helps you to efficiently search a particular location and store the element into that particular location. So for that, there are different things that you have to know. You have to know what is a hash table. You have to know what is a hash function, and you have to know what is a key and different terminologies. Here, this accessing an element is quite faster than the other techniques like binary search and a linked list search. So compared to the other techniques, here the hashing is quite faster than that because it takes the time to access an element big O of 1. So let's learn about the different terminologies used in hashing. So terminologies, now if we are going to think about a file, now here F is meant for file with n records, and you have a table called T with m memory locations and key set of keys which uniquely determine the record in file. That using that key you're going to find the location where to be stored inside the file. We'll see that in a next slide. Now L is the set of memory addresses. That means it is a location in that particular. H is the hash function, K is a key, and that particular key record should be stored in which location? L location. That is what this means. So apply some hashing function on the key, and then using that hashing function and key, you're going to find the location and store the record in any location. And if you want to retrieve that record, you can use the same hashing function and retrieve the record. So for example, now suppose this is your file, and this is your file, this list is your file, and 11, 13, 16, 15 and 33 is a key. That means it is records that you want to store in this table. Which table? Hash table. In this table where I'm pointing to this, to the the mouse is pointing on that table, right? So now you want to store 11, 13, 16, 15, 33 in this hash table. So imagine that this is a file which has how many records? You 1, 2, 3, 4, 5. 5 records. You have 5 records, and these are the keys. And what you're going to do is, for this example, I've used one hashing function. Hashing function is h of x. So we saw here h. What is h? Is hashing function. So this is the hashing function of x. X is actually the key. Okay. So now here I want to find the location for 11. 11 mode 10. So this is what you're going to use as a hashing function. So your hashing function is h of x. So in the previous slide you saw what is h. H is a hashing function. K is a key. So here x is the key. Okay. Now what is our function here? X modulus 10. So if you get a reminder, that reminder will be the location of 11. So let's work on the first record 11. Apply the hashing function 11 modulus 10. The reminder is 1. So this 11 should be stored in which location? First location. Now next record is 13. So where to store 13? So you're going to use this hashing function and apply it over this key. So 13 modulus 10, it will give the reminder 3. So this 13 will store in this 3. Next is what? 16. 16 modulus 10 is 6. So that means you have to store this 16 in 6 location. Now 15 modulus 10, it will give you 5. So 15 is stored in 5th location. Now 33 modulus 10 will give you 3. So it will go to 3, but already there is some other number which is stored, or the record is stored. So now if you want to store 33, this 13 will be removed and 33 will be replaced on it. So this is known as collision, where 13 is already existing and again in that same location 33 is going to come. So this is known as collision. So you have to avoid collision when you are working on hash functions. Okay, so I hope this is known as hash tables, and this is the hashing function. This is the hashing function, and this hashing function is applied over each and every key, and that when you apply, you will get a particular location where exactly that record should be stored. Okay, you're going to learn about hash functions. Here it has mentioned that to achieve a good hashing mechanism, it is very important to have a good hash function. So, what are the three basic requirements for good hashing function is that function whatever you're going to pick should be very easy, and also uniform distribution means it should provide uniform distribution across the hash table and should not result in cluster. Then less collision. So when you pick a hash function, that hash function should be efficient enough to avoid collision. So these are the three requirements when you design a hashing mechanism to find the location of a record. To learn some of the popular hashing functions. Um, there are many hashing functions. From that, we picked three. So the first hashing method is known as division method. So division method. This is the formula that is that you're going to use and apply to find the location for the record where you want to store. Now here, how do we do this? So now here you know what is H. H is the hashing function applied over key, the key that you have taken. K is the key. And what is M? You have to know what this M is. So how do you choose M? So choosing a number M should be larger than the number of keys in K. Okay. So we will see an example. So it says that it is always good if we choose M, which is if you're going to take a prime number uh, for M, it says that it will minimize the number of collisions. So let us see with an example how can we do that. So now here there are two formulas that is given. This formula in case if your table is starting from 0 index, and this is applied when your index is starting from 1. So if you're going to start your index with 0, you apply this. If your index is starting with 1, you have to apply the second method. So the next one is here there is an example. Now consider there is a company with 68 employees and each employee has 4-digit employee number, like as if you have a student ID. And suppose L contains 100. L is what? The location in the table. The number of locations inside the table is 100, which is 2-digit addresses. So it is starting from 00. You have 100, right? And 100 locations you have. So it will start from 00 to 99. So next step is what is N? So that is what this table will look like. See, the index starts from 00 to 99, which has 100 locations. And you want to store each and every employee number into this table using a hashing function. Which hashing function you are going to use? Divide method hashing function, and store that particular record in this location which has 100 addresses. Now what is our equation here? The equation is h of k is equal to k mod m, or you can use k mod m plus 1. But in this case, your index is starting from 00. So we are going ahead with the first um, equation, first method. Okay. So let's see. Now, what is so in this you know that in this you know key, which key. So now I'm going to opt for this key, 3205. I have to find the location where to store 3205 in this particular table using which function? This hashing function. So we're going to use this. Now we have to know what is M. So there is a condition for M. So you're going to give a condition saying that let me pick a prime number which is close to that the size of that table. So here the last index is 99. So the closest prime number to 99 is 97. So you got M. Now you apply the hash function. Now you want to find the address for 3205. So what is the equation? H of 3205 modulus M. M is what? 97, which is a prime number which is close to 99. So you got the remainder as 4. Modulus gives you the remainder of that particular division. So when you divide this 3205 with 97, the remainder is 4. So 4 at fourth location you are going to put 3205. The next one is what? Hash. Next key is 7148. Now you want to find the location where to store this 7148. where to insert this. So now 7148 modulus 97. M is what? 97. So 97 gives you 67. So as in there's a limitations in the space. So I've made one 67, and that 67th location you're going to store 7148. Next one is what? What is the next index? 2345. So 2345 modulus 97 will give you 17. So go to 17th location and store 2345. This is this formula. That is which formula we are using? We are using this, the first formula, as in the index starts from 0. If your index is going to start from 1, you are going to use this formula. That's the second formula. So this is a first method, which is known as division method. Next method is known as mixed square method. So here how you're going to work on this is, if a key is given, first step is to square the key. So now here the key is 3205. So you take the square of 3205, you'll get this square. And then next step what you have to do is from right to left. From right to left, you can decide, like, you have to find the middle number. You have to pick the middle number as a location. So here, as in the address, this is 2-digit number. You have to pick any two middle numbers from this set. So now here in this example, they have fixed fourth and fifth number. When you count fourth and fifth number from right, that will be taken as address. So now here, when you count from right means 50, 520, 24. So 1, 2, 3, 4, fourth and fifth number, that will be taken as the address. You got it? So that's how it is here in this mid square method. The strategy is as such. So next example is here. The key value is 7148. You square it, and from right in the sense from this side, fourth and fifth, 1, 2, 3, fourth and fifth, these two will be the address of this location. Now here, when you add this, when you square this number 2345, when you square it, fourth and fifth, that is 1, 2, 3, 4, 5, 99 will be the address of this. So you can decide. It depends upon the strategy that you're going to use. So here the strategy is, you square the number and pick the fourth and fifth number as you're coming from right. Okay, so this is known as Smith square method, and the third method is known as folding method. So what are you going to do with folding method? So in this example, here the key is 3205. So what are you going to do is split into two pieces, 32 and 05. So 32 plus 05, that will give you 37. At that particular location, you're going to store 3205. Next one is 7148. You're going to split into two pieces, 71 and 48, and add it. So you'll get the address, 2-digit address, but actually it is 119. So you're going to skip the carry there. You're not going to take the carry. You ignore carry and then take the other two numbers. Okay, so now next one is what? 2345. So when you add this number, 23 plus 45, you'll get 68. So at 68th location, you're going to store that particular key. Got it? So another way of doing folding method is, you divide the key into pieces, that is 32. This one, talking about this alternatively, you can do another technique. 32, instead of 05, you reverse that particular number. Second key will be reverse, that is 50. And then add, you will get another address. This is another way of doing it. This is 82. So 82nd location, you're going to store to 3205. The next one is 7,148. So in that 7,148, in that you're going to split into pieces, 71, and instead of 48 you're going to make it as 84 and add it. So you get the address and ignore the carry there. Whatever balance 2-digit number you're going to get there, you're going to put the address. So this is known as folding method.